In this video, we'll be covering the basics of the 4 primary building blocks of Minecraft Redstone. The first is the redstone block. The second is the redstone torch. The third is redstone dust. And the fourth is the redstone repeater. To illustrate the properties of each of these, we're going to place down a lamp, which is a redstone lamp specifically, but a Minecraft block that will interact with the redstone signal when it receives one by lighting up. Now in this case, we've built a wall that is 3 wide and 3 tall, and we're going to go ahead and punch a hole in the center of it. And now we're going to go ahead and place a redstone block in the middle. We can see that the lamps on all sides touching it have lit up. If we place 2 more, we'll see that those lamps have also lit up. What you're currently seeing is the redstone block is putting out a redstone signal. So the 6 sides of the block act as 6 different outputs, but it will not receive an input. So it is a power source block. It only ever outputs that power to whatever block it's touching. The next principle would be that of the redstone torch. In this case, a redstone torch acts as a powered block, a powered source, and a block that can be activated. Now, what this means is if a block is to be placed directly above a redstone torch, it will light up, as would be expected for a redstone signal. Also, if you place blocks around it, they will light up as well. The difference, however, being that if I were to place another lamp either on top of, beside, or next to any of the 4 lamps that are beside the side of the torch, not above the top of the torch, they will only react to the redstone signal. They will not become a powered block themselves. However, this is not the case if you place a block directly on top of a redstone torch. The redstone torch is acting as an output to send redstone signal into the block above it. This block has now become powered, so if I were to place torches on either side, any of the 5 remaining sides of that lamp can also now light another lamp. However, those in turn will not start new lamps. The other aspect of a torch that is very important to know about is the fact that a torch will allow for an input on the bottom. So in this case, we'll put a torch directly on top of a light, and we'll use a lever for this example. If we take this lever and place it on the side of the lamp, and we'll demonstrate over here real quick, a lever is a player-controlled object that will have a constant output of either on or off. And default behavior down is on, or a redstone signal out, and off is up. So with this flipped down, we notice this lamp will come on. We can do the same thing over here, but now the torch has gone off. The reason this torch is off is because the redstone block is currently being powered by the lever. And this redstone lamp is acting as a powered block, and the torch has an input on the bottom of the stick that whatever block it attaches to, it will react to the activated state of that block. The same is true for this if it is placed on the side. So if I were to put a redstone torch on the side of this, and I were to put a lever on it, it would act as the block that it's connected to and would turn off the power to that torch. So a torch essentially has 3 properties. 1, it accepts input from the object or block that it's connected to. 2, any block that's on the side of the torch will actually react to that torch based on whether it's on or off. And any block directly on top of a torch will not only react but also become a power source in its own right. So when I flick this switch, we'll see that this one came on because it was activated by the side of the torch, and these two came on because this one was powered by the torch and it in turn powered that lamp. And this principle would also work if I were to place a lever on this lamp and put a redstone torch on the side. We'll see that the same thing will occur, except since this block now occupies what would have been the side space of this torch, the activation of this torch is now propagated downward. So this torch will activate on one side a lamp, on another side a lamp, on a third side a lamp, and on its fourth side it would actually activate whatever block is below it. The next redstone block that we're going to look at is going to be redstone dust. Now redstone dust itself is a very interesting component of the redstone system in that it acts as nearly a universal input and output device, meaning that it will take a signal from any side and will output to any side available except for directly above it. So what we have here is a line of redstone. Now if I were to put a redstone block at the end and power that, we'll see that it has lit the lamps under each piece of the redstone. Those lamps in turn have become power source blocks and have activated the lamps underneath them. Now, any block that a piece of redstone is on will become an activated block or a power source block, which in turn will activate other blocks so long as the redstone is on. Now, if for some reason the redstone is off and there's a signal directly above it, it will still receive that power downward. However, if we were to put a lamp above this redstone, you would see that it does not come on. Now this behavior of only lighting up the blocks in relation to the power source is a standard behavior for redstone when it's running in a line, or what I like to refer to as being focused. If I put a lamp on either side of this, you'll see that it does not come on because of the fact that the redstone is only powering the block that it's on top of. However, if I were to take this redstone and make it so that it was no longer focused and had no specific point to go to, it suddenly lit up the torches on the lamps on either side of it. This is because of the fact that an unfocused piece of redstone will make any block that is beside it or beneath it a powered block as well. So what you'll see is that I can actually go ahead and put a large number of lamps all the way around that one piece of redstone, and they are in fact being lit only by that single unfocused piece of redstone, sending 5 output signals around it from the one input signal it's receiving from this redstone block on top. The last component of the redstone system that we're going to cover will be the repeater. In this instance, it is the only device that is going to allow for a secure input and output without lighting up any other blocks. What we'll do is we'll put a lamp here, and we'll put a repeater behind it, and we'll go ahead and give that repeater an activation signal by putting a torch behind it. We'll see that that lamp is now lit up. I can connect other blocks to that lamp and they will become activated. However, the repeater will not activate a lamp on the left, right, above, or below it. The reason for this is the repeater is an input and output only device. It accepts only one input and puts out only one output. Anything touching the other sides of the repeater will not receive the redstone signal. In addition to this, you can actually delay the amount of time it takes for a signal to travel through a repeater by right-clicking on it to adjust the number of delays. These are referred to as ticks. You'll notice that if I were to build two exact copies of the same device and place some lamps here, and then go ahead and were to place a repeater here without adjusting the ticks, and connected both of these by redstone wire, that the lamp in the back should turn on approximately half a second before the lamp in the front, which has a 4-tick delay. Now, this is one of the primary ways in which redstone can be used to create timings and gates for programming logic. With these four aspects of the redstone system, we have the ability to create a insulated input-output signal with the redstone repeater, a ability to send signals over a great distance by connecting redstone dust, though it is an uninsulated power source, and the ability to control input and multiple different types of outputs through the torch, and a constant output with the redstone block. This allows for almost any replication of standard electrical or electric signals that are used in machines, computers, programming logic. It is essentially the building block of all electrical engineering systems in terms of input, output, constant on, constant off, and the ability to switch between those states.